All right, welcome everyone. So last breakout session for the day. We got keynote left. Everyone having a great time so far? Yeah, it's really great conference. I've been enjoying myself. Although sure enough, I just flew in this morning and I slept nothing on that plane last night. So after the speaker dinner, I'm crashing. And luckily tomorrow I have no talk, so that's good. All right, so for the next 40 minutes, I'm going to be talking about durable functions, which is an extension to Azure Functions. They are something that have really helped me out over the years. We've built some really interesting stuff with them. But the first question that I like to ask, and maybe, come on. It was working right before the session started. My whole computer has froze up. Hold on a second. Wow. PowerPoint has just decided to die on me. Let's try that again. There we go. All right. So, question I always ask before I start the session, how many folks actually have used Azure Functions before? Okay, great. Most everyone has. I ask that because actually a lot of times when I present this, I usually get most people haven't. So, with that being said, I'm going to go through the next couple slides because I have introductory slides. Actually, I don't even need to do that. Remember, I put a link in here. There we go. So we can go straight to this. So real quick, for those who, there were a couple who haven't done much with Azure Functions and so forth, which if you've done AWS Lambdas or GCP functions, it's all the same idea. The idea that we have serverless functions. So you're just writing little bits of code that are triggered off of different actions. And those actions could be things like files being added to a file store, or a blob, or an HTTP trigger, or messages going to a service bus or to SQS if you're inside of AWS and so forth. But the key tenets are, with Azure Functions, is that it's stateless, short-running, event-triggered serverless computing. But the question comes up, what happens when I need state? I need to actually keep track of what's going on. What happens when I need to do workflows? And this is something that, that are long-running. Azure Functions in and of itself don't handle these very well. By default, if you don't change any settings, it at least used to be, it was 15 minutes. Actually, with different SKUs of Azure Functions, they've changed it around a little bit. But, they really only tend to run for seconds, right? As a matter of fact, Microsoft tells you, outside, unless you go to premium functions and you pay for those, they tell you pretty much 5-10 minutes. Right, and if you're running longer than that, you need to re-engineer because you're going to have problems. That's where durable functions came out. Now, again, when we talk about long running, what we really mean are things that take a long time because they're doing a lot of different tasks and so forth. And that's kind of what we have with durable functions. So as I mentioned in the open slide, it is an extension to Azure Functions. So everything you do in Azure Functions works within durable functions. It's basically an add-on to this. It is done by Microsoft, so it's not a different team or anything. It's just built inside within there. But they purposely have kept it separate because there are some things it does differently. The next big thing is that it allows you to write stateful, and I purposely put that in quotes, in a serverless fashion. All right, and again, the state is keeping track of is where are we at within a workflow? What has been done, what hasn't been done, right? And it can do some aggregate stuff, and we'll talk about that. But then the other big part is defining workflows in code. So sure enough, in Azure we have things like logic apps, and there's other tools that are like that. Make it really nice and pretty, so I can just drag over things. But in reality, especially as developers, is that really what we want to use? No, we want to write code. We want to write C# or Java or what have you, and actually define what we want to do. We actually want to be able to easily see, well, when this exception happens, this is what we're going to do with this. And that's one of the things that the durable functions provides because it's all code-based. So, if we were to look at it a little bit deeper, like I say, we're defining the workflows so we can have things like parallel execution. We can have error handling. The orchestration functions are very easy to understand. I'm about to show code examples, and you'll see it's just C# code. And I will say this: I keep on saying C#, Java, PHP, F#, JavaScript, Node in particular, all the same thing, right? Because one of the things that Microsoft did about 2 years ago was they got all the languages, in parallel. And they're guaranteed now is that they will keep all the languages in parallel, so that any feature they add will be added for all languages. So again, we have this very easy to do, and again, lots of different workflow patterns. So things like fan out, fan in, function chaining, human interaction, and I'm going to go through each one of those, so you can see more what we're talking about. And then again, solving that state problem, because you don't do anything for it. The most you'll ever do, and that's if you really need to, is decide that, Azure storage isn't good enough. I actually need to go to the Cosmos. And honestly, I have never gone over that, and I don't know anyone who has. I know people have, but I haven't met anyone, just because, mostly the Azure storage does a great job of doing it. But the great part is outside of that options, you're not doing anything. It's the same storage account that you use for a normal Azure function. It's just using other parts of that, right? They're using table storage more and queues and so forth. So some of the basics. So as I said, you're defining your workflows in code. It's very easy to implement this because it is just code, right? And it's just C# code. Now, easy, I do put a quote around. Try debugging it, and it's a real pain, because it's async code, right? And it's async inside of async inside of async, all right? So it is a little bit of a nuisance to do this. You can consolidate your exception handling. One of the great parts is you can actually track where you're at in a workflow. And I don't have it in this slide deck, but they've actually also introduced, and I'm actually drawing a blank on what it's called right now, but they actually have a new state engine that's actually giving you even more tracking information, even deeper than what was already built in. And then finally, again, like I said, they're managing that state for you. So key concepts. So I mentioned this already, orchestrator functions. So basically, just your C#, Java, or what have you, functions that basically say, okay, we're going to do this, then we're going to do this, and we're going to do this, right? I mean, it's very simple. It's orchestrating what's happening. And what it's those calling things is activity functions. And I should say, again, if you're used to Azure Functions, Azure Functions has its trigger types. Orchestrator is a trigger type. Activity is a trigger type. And sure enough, orchestrators cannot be called by other things other than starter functions. And activity functions can only be called by orchestrator functions. So you can't mix them. And they're not meant to be, called off of another trigger, right? They're only called from that orchestrator function. And then finally, you have your starter orchestrations. And these are just regular functions. So whether that be an HTTP trigger, a message bus, whatever you need to trigger off that event. One thing I will tell you that I always like doing, like for us, at our company, we do a lot of event-driven architecture. And so we do a lot of things off of service bus. But we almost always have an HTTP trigger that's also triggering that orchestrator. Because there are times you just need to debug stuff, and it's a whole lot easier to do that than have to create a message and all that good stuff. So we like doing that also. So the workflow, so you have your client function that service bus message. It calls in, and we'll look at the code here in a moment. But basically, you go in and it makes a call to this orchestrator function. You're actually starting the orchestration. And in there, that activity function, or that orchestrator function, will call an activity function. And then what happens is that orchestrator goes to sleep. So it's not operating while the activity is operating. But it keeps on waking back up, right? And but for milliseconds, right? 1, 2 milliseconds. And what it's doing is doing a check state. And it's saying, hey, is it activity done? No, it's not done. Okay, let me go back to sleep. When it is done, it says, okay, great, I got that response. And now what's the next thing I need to do, right? So maybe it's call another activity function. And then, gets that response. And sure enough, You can have a durable function that just calls one activity, right? You're not getting the full benefits of this, but there can be use cases for that. All right, constraints. I've been talking about how awesome these are. There are constraints. And it's a big one, which is why I've got it blinking and red and yellow. There's a reason why, and that's the deterministic APIs. So as I mentioned, the orchestrator keeps them going to sleep and is being wakened back up. So there's things that happen that we have to be careful with. For example, date times. If I just do a normal, date time get UTC now, what's going to happen? Well, every single time it wakes back up, it's going to generate a new date time. And that's probably not what you wanted. Because you probably want it like the date time when this thing started or what have you. So sure enough, what Microsoft has done is they've added a, what do they call it? They called it so within the context, there's a current date time UTC. All right, and what that's guaranteeing is that we'll only ever generate that once. Because basically, as far as the durable function is concerned, that's basically like an activity that it's doing. It's just that it's an extremely simple activity. So date times, GUIDs and UIDs, random numbers, bindings, static variables. These are all things you need to be concerned with. Environmental variables, things that you don't necessarily think about. And the reason why Microsoft cautions on this is because the environmental variable, this is long running. What happens when that variable changes in between the time that thing started and the time it ended? So, the general recommendation is in the starter function to get those environmental variables and actually feed that into the orchestrator. Network and HTTP thread blocking APIs, because you're doing async work. You got to be careful with those threads. Async API, same thing. Threading APIs, right? Of course, sure enough, really, if you're dealing with threads, one, I ask you, is that really what you should be doing? And two, God love you, because that's complicated work already anyways. So, all right, we've been talking about what these are. Now, what can we do with them? All right, what are the normal application patterns we would see this? And there's a set of 6 that we normally see. All right, I'm going to go through each one of these, and I'm going to show code of how these are implemented so you can see how easy this happens. So the first one is function chaining. Actually, you can do this in a regular Azure function. The idea that function 1 does something, and it calls function 2. That does something, calls function 3. That does something, calls function 4. And you could do this today in a regular Azure function. But what's going to happen? Function 1 is going to start up, and then it's going to call function 2. It's still running that whole time, all right? Function 2 is going to start up. It's going to call function 3. Function 2 is running the whole time. So basically, you have 4 functions that are running at the same time, for different periods of time, which means you're being charged for that. And again, I go to conferences, literally all over the world, talking about how awesome Azure Functions are, and one of the things I talk about is how great the costs they are, except for you do stuff like this, right? Because now you've blown up your cost. With durable functions, again, it's putting those to sleep, right? So it's calling that function. The orchestrator is actually the one that's calling these, and that's what makes this a whole lot better. So scenarios you would use this in, like order processing. Basically do this task, do that task, building on top of these things. Image processing is very common here because a lot of times you'll start doing something, add a filter, and then you add another filter. Maybe you'll crop it. Data migration, where you're transforming data, but then you can't do the views, until after you've done some other work. Approval process, normal process. Report generation. So here, collect data, process data, generate report. So that's what I'm going to show here. So in this example here, we've got 4 activities. And again, wonderfully named, right? Fetch data, fetch more data, right? So awesome names for functions. Actually, this is when I get upset with my developers when I do code reviews and I see names like that. I'm like, let's give it better names. But for demo purposes, it works. So you have your orchestrator, like I say, it will call these one by one. And you have your starter. So what does this look like in code? So first off, here, this is an activity function, all right? And we know it's an activity function because it's got that activity function or activity trigger, all right? So same syntax you would normally use for any other type of Azure function, right? You're doing. And then you're taking in a function context. And then about the only other difference is that you're dealing with that function context. So like that's how I get my logger, right? If you're going to do logging, which you should be, right? But everything else, it's just a normal Azure function, all right? You wouldn't normally delay for a second, but this is actual code. So sure enough, I'll have the repo at the end, and you can get all this code. But other than that, and then the one thing I was showing here is that you can return data back, right? So we have that. Here we see another fetch more data, right? Basically the same thing. So here is our process data. So now what I'm showing here is we're also able to send data in, right? So just showing, again, things you would normally think of, but I want to make sure everyone understands that. And then we have generate reports, which, here is where we're saving it to a blob. Again, nothing in particular with being a durable function, but I am showing you have full functionality with this. Actually, you could do this through output trigger or output bindings, but I'm not a big fan of output bindings, so I generally do it on my own. So that's the reason why I do it that way. And then finally, here's the orchestrator. And this is what I was talking about. This is really simple code. There's nothing much to this, right? So we have here, the orchestrator trigger, right? So it's just another type of trigger. Again, it's a special kind of trigger, but then we're just making 4 async calls, right? So it's easy peasy, right? Context.call activity async. That's the only thing that makes it, an activity trigger at that point. So, so when we run this, I'm sorry, no, I've got my starter. So here's the starter. What have I got? I've got a HTTP trigger in here. So just like any normal starter, nothing different with this. But then here we see we are bringing in a durable client. So that is one thing you have to do differently. And then finally, we see this. I'm getting an instance ID, and I'm scheduling the orchestrator. And that's what actually will start that work. And what's really important, it actually returns some really important information that we end up returning back here in this, check status, right? And we're about to see this. So if we call this, and here's, again, if you've done Azure Functions before, you've definitely seen the screen, right? So again, for those who haven't done Azure Functions, one of the awesome parts is I can run them completely locally, and it's not an emulator. It is actually Azure Functions, right? The only limitation is that it can only be localhost. But everything else is, and when I say only localhost, like you can still do service bus connections, all that good stuff. But notice we've got a lot in here, right? Because everything does show up. And that's one of the things that does trip you out a little bit because, like I said, you can't call any of them, right? I can't say I'm just going to go and call that generate report, right? There is no way to call it. But they do show up in there. It does show it's an activity trigger, it's an orchestrator trigger, and so forth. So if we go to Postman, we do a post, and then we get a bunch of links. The important one, they're all important, but the most important one here is the status. Because you want to, I told you, you get status, so you know what's happening with this. If I open that up, I'll see something like this. And so we're getting a lot of good information. We're seeing the name of it. We're getting the instance of this. Durable task schedule. That's the tool I was trying to think of earlier before. That instance ID becomes really important in DTS because that's what you're going to be looking at when you're using that tool. But again, the important part is I do get status, right? So I see runtime is running, right? If I call this again, it's now completed, right? So very simple status, but I am actually getting status of what's going on here, right? And then I also get the output. And in here, I passed a URL. It could be data. Again, it's just string essentially, right? Because it ends up returning a JSON object. In these type of examples, I do like storing it into a blob and then giving you that URL to that. But that has nothing to do with durable functions. That's just general programming. And here we can see this awesome report that got returned. All right, so that was function chaining. So fan out, fan in. So here we're talking about the idea of, what happens when I have a lot of work I need to do, a lot of repetitive work, all right? Think of your batch jobs where it's just going to do a whole lot of things. And what's usually the biggest problem we have with that is the time it's going to take to run those things. Well, remember, what does Azure Functions do? The idea of one of the ideas of Azure Functions is that the more work I give it, the more instances it'll create, up to a point, obviously, all right? So that's what we're doing here. Hey, I've got a lot of work I need to do, a whole bunch of things, basically the same task, but slightly different data or what have you. So let Azure Functions do its thing, scale up those things. Again, you're not being charged. You don't get charged for the number. Well, that's not 100% true. You do get charged for the memory you're using for each one of those. But you're spending a whole lot of time. So in the end, you're not spending more than if you ran them sequentially, at least, right? And it really does depend on exactly what you're doing, is whether you're spending less. But again, think of like batch data processing, stock price analysis, rendering videos. Concurrent API calls is a perfect example of this. But the example I built here was web scraping, all right? So actually, I built this example before AI became the big thing. I guess now I could do it like AI scraping or something. But the whole idea, hey, we need to scrape these pages. So in here, I have just the one activity function, just my scrape web page, all right? The orchestrator and then the starter. So again, that starter is going to call. The orchestrator is going to say, oh, I've got a lot of work I got to do, so I'm going to spin up all these different instances. And again, we're about to see the code. I didn't do anything for code other than something, just a neat little trick. So again, we have our activity. There's nothing special with the activity trigger other than what it's doing for this job. I mean, here it's reading an HP page and it's looking for the title, right, is what I'm doing here. Here's our starter. Basically the same thing we saw in the first starter. So our orchestrator. So how do we get this fan out? Well, I basically create a list of tasks, and then I put them in. I put them in that list, and then the middle line is the big trick. It's that task win all. And Durable reads that and says, "Okay, let me go spin this off. Let me spin up a whole bunch of instances." And again, all really Durable's just doing is just giving Azure Functions a whole bunch of work to do. And a regular Azure Function job kicks in. The scaler kicks in, does what it does so wonderfully. And I will say, Durable or Flex consumption has made this even more cooler, right? Because Flex consumption will actually scale out even more quicker, and we'll spin them down a whole lot quicker also. So really interesting stuff we can do with that. And then the fan in is the part I can actually aggregate the data, right? So I get the data back. I'm in here, I'm getting it as a dictionary. And then, here I'm just adding to the scrape data. But, again, do what you need to do for your use case. All right, the next one here is async HTTP APIs. I cannot say that quickly. And really, we've already seen this, right? Because this is already, this is actually working in every single Azure Durable function. Here's the idea, truly a long-running process, right? You're going to do something that just takes a long time. And what is the definition of long time? Again, depends on what your customer needs are, all right? Long time could be 2 seconds. Probably not going to go to that extreme, but 5 seconds, 6 seconds, right? The part where you're not necessarily having someone just wait for a response. They're going to go pull that response. So basically here, we're starting work, we're having that work happening, and it's keeping track of this. And basically, I can then, remember that get status? I can now call that get status. So again, just spinning off a lot of work that happens, takes a long time. Again, video processing is a common example of a lot of these. Report generation, image recognition, machine model training, a long-running database operation. So here's a perfect example. Although, actually this week I was dealing with this, and it was actually a report generation. That was the exact problem we had this week. So in here, again, your heavy starter, your orchestrator, and it calls that long running operation. And that might be a lot of different operations. The point is we're just talking about the simple part of the pattern of this. And what we're going to see is nothing changes, right? The starter is the same starter we've seen before, other than what it's doing for this job. The orchestrator is doing exactly what it did before. There's nothing different in here. Even the long running operation, other than the fact I'm waiting for 30 seconds, all right, just so I can simulate something that's going to take a long period of time. All right, next one is monitoring. Basically, the timer function on steroids. And so what we're talking about here. So again, for those not new to Azure Functions, one of the trigger types we have is timer functions. Probably the second most used trigger, the most being HTTP triggers, and then timer triggers. Especially at least in conferences, because that's what everyone demonstrates. Is first the HTTP trigger, and then demonstrates the timer trigger. And again, the idea, hey, do a task every 5 minutes, do a task on the second hour of the 5th day of every third week. Whatever. It's just a cron expression. But what happens with these when let's say you're doing it every 5 minutes, but a process takes more than 5 minutes for some reason? Do you want the timer to restart? Probably not, because it's probably going to mangle up data. Or what happens when you say, okay, we're going to do this every 2 hours unless something goes wrong? Then we want to do it every 5 minutes, right? Like a learning type situation, all right? That's where monitor comes into place. Because on a timer trigger, the only way I can change that timer is to recompile the function app. Because it's built into, again, what recompile, I can make it an app config setting, but the only way to get that applied is to actually restart the function. Whereas here, I can, again, it's just in code. So again, think of it like your batch job monitoring, health monitoring. Notice monitoring comes up quite a bit here, right? The one I have here is a website availability monitoring. Perfect example of this. I'm sure this is what Azure was using last week when they had their nice little outage. That was actually our first big outage since I just released something where the whole company is now using it, and they're new to Azure, and I was, oh, great. Please don't go down on me while. But anyway, so in here, again, we'll have our starter orchestrator. So here the orchestrator will call that normal activity, the check web status. I think I have it doing like every hour or whatever. But then when something goes wrong, then it starts sending alerts. Hey, the site is down, or it's not responsive, what have you. Now here we start seeing a little bit more code. All right, this is starting to get a little bit more complex. Here's our activity trigger. It's not that complicated. Plus, there's a table client because I'm saving data in here. But there's a little bit more code in here. Our send alert. Here we're just sending an email out to this, so nothing that special. I will say, quick little plug. There's also Azure Communication Service, something most people don't even know is out there. It's actually a real easy way to send emails with inside Azure Functions and other C#, well, not just C# code, but that's actually demonstrated here. Your starter is basically the same thing. So your orchestrator. So here we're setting up a monitor for every for 24 hours. All right. So basically, what that is saying, run this for 24 hours. Right. Not run it every 24 hours, but run this for this whole code for 24 hours. And then what's key here is at the bottom, that's where we're changing the intervals, right? That's the whole point I'm trying to make is here. We can change those intervals. And while this code is showing it only runs for 24 hours, we can run that indefinitely. It's not like it has to run for 24 hours. And I'll actually show a screen that shows that. But so, really nice, because again, like I say, I can change these, right? And these are, we use this a lot for, So I didn't talk about what I do. So I work for an engineering manufacturing company. So we have a lot of monitoring that's checking for what's happening with the different lines, or when things are, basically when they're going to fall off schedule. And we actually have a couple of durable functions. That's exactly what they're doing. Is they're doing normal checks every hour. Well, it depends on which area it is, but normal checks what it's supposed to happen. And whenever they fall behind, it starts doing more checks to see, well, how quickly are they getting caught back up. All right, the next big one, and really the last big one, there is one more after this one, but the human interaction. And again, don't hang up the name. It doesn't necessarily have to be a human. The point is that basically there's an action that has to happen. So here, normal thought is a request for approval, right? So you send the request over to the person, and then they process your approval. So we're all here at a conference. Probably a bunch of us need to submit expense reports after this. You send it over to your manager, you get approved. And what happens? The manager doesn't approve it right away. Well, one of the things that this pattern helps with is escalation. All right, so after an hour, escalate that. And again, don't think about just for a human approval. This could be, machine process not happening as quickly as you want to have it. One of the things I've seen is with help desk, and tickets get open and they're not, the goal is to handle it within 20 minutes, and it's not happening in that type of goal, right? So that's things I've seen with these type of approvals. So again, your normal is your approval workflow. That's what you'll normally see it written up as. Your expense report submission, I think it's normally you'll see support ticket escalation. I've actually done that before, right? Survey or feedback collection, right? So think of the idea of you put out that survey, but you close it, So, Øredev is done. They send out a survey, hey, tell us what you thought about it, but they don't leave it open forever, right? After 5 days or whatever, they close that. That's kind of what we're doing there. Or another one that you don't normally think about right away, but user registration. You have the whole thing, hey, you've registered for an account, and I'm going to send you an email, or I'm going to send you a text message so you can confirm that you are who you say you are. All right, and this is a perfect example of using this. So here we'll have the starter, calls the orchestrator, and the first activity it's going to call is that send challenge. And then basically, if you remember from the screen I showed you where a whole bunch of links, one of those was a link to post data back to the orchestrator. So that's what would happen. The orchestrator gets that post back and will call the record challenge status. So in here, now again, the orchestrator is getting a little more complicated. But so the first part we see in here, first off, we're creating the challenge. So one of the reasons why I want to show this off, because we talked about keeping state, but it doesn't keep this kind of state, right? This is stuff you still have to handle, right? But it's going to, so I'm just using table storage. I absolutely love table storage. I use it all the time. It's really great for simple little things you need to keep. In here, now, the way how this works, this is the way how the timeout works, and I should say the escalation works, is you actually set in an async, but you're actually setting up an expiration in there, right? And then with the timeout. So that's the way how that's working. And then here's where we're actually getting the data, that post back. And in this example, we're giving them 3 tries to get it right. And you can see, it's doing a win any to see when it wins. And if it wins, then it'll successfully complete. Or if it times out, then, we'll do the timeout expired logic, right? Which in this example is going to time out the challenge. Again, like an expense report, maybe it's going to send it to someone else to be approved. All right, the last pattern, and there's a reason why I put this last. It's the one I don't like. The aggregator pattern, or stateful entity. So durable functions can keep some state, just not very well. And I will admit, I never use this thing, because every time I try, it never works for me, and I just do other methods. But it is the whole idea. Think of getting data constantly and aggregated, like weather data, right? Maybe every 5 minutes you're checking the weather and you're getting the average for the day, or sales data aggregation, log data, social media mentions, or stock market data aggregation. To show you how much I don't like this pattern, I didn't write code example for it. Actually, I started to, and again, I was having trouble with it, and I said, never mind, because I don't even recommend this pattern. But it is one of the patterns Microsoft talks about. I have actually seen demos at work, usually very simple. The demo I've mostly seen at work is a step counter. And I'm like, that's like the most useless demo I could ever think of. But there is that. All right. So that's all the patterns. So a couple additional details, because there's a lot more into this. Because sometimes orchestrations get complicated. I mean, if you see some of our, I'll tell you, if you see some of our durable functions, they'll have 30, 40 activities that are going on, because there's a lot of branching and all that good stuff. And one of the things that Microsoft did was they had sub-orchestrations. And it's literally called a sub-orchestration. You're actually calling off, and you know, it's actually another type of trigger. So I really like the way how they did this. It basically helps me organize this a whole lot better, right? Because again, while code is nice, code quickly gets to be a mess, right? And here's a great way to simplify that mess, right, and make things a lot easier. The next one I want to talk about, so the status. So if you go in and create a new Azure durable function, this is exact code you're going to get, all right? And so here, this is an example of a function chaining, because it's going to call 3 different functions in order, all right? And it's going to say hello to Tokyo, Seattle, and London. So, you know, nothing all that special. And when we run this, you know, again, we're going to see exactly what I showed before, right? So I do see it's running, but where is it at? How do I tell what's going on, right? I mean, it's great it's running, but, you know, is it almost done, or is it just getting started, you know, what have you? So one of the things they've added in here is you can actually set a custom status. It's just a value, right? Now, again, it's a string value, so that can be JSON or what have you, right? And here I'm just showing it's not really all that useful, because you have to know what order this thing happens in. But I mean, again, you could do simple things in here, but real easily put in status. And honestly, that example was really kind of too simple, right? But think about how we could do this in real, you know, scenarios where maybe we're providing a percentage or that type of thing. We're actually providing status of where we're at in here. And again, think about, you know, when you've got a consumer that is waiting for a response, and so they can actually query the HTTP trigger and find out, you know, or the HTTP async trigger and find out, you know, hey, you know, they're almost done. Good, we can almost finish this up. All right, I did talk about this, you know, in that one example we had the when or while loop. You can also do a continuous new, and so literally it will finish the whole thing and it will just repeat it. And it will repeat it forever until you actually stop you actually have to stop. What was you have to do? Did I write in my notes? No, I didn't write in my notes. You can't, these don't just stop cleanly. That's the one thing you gotta be careful with this. Because the one thing about durable functions is you stop the Azure function, it's still running in the background, right? It's just stopped. But the moment you start that Azure function app back up, it kicks back off right where it was, because it's all kept in data, right? And actually, I could not remember how we have to stop actually stop. I mean, you might have to actually go into the table storage and clear it out. I can't remember. All right, so I'm gonna wrap up with some, because I'm almost out of time, but I will finish just about minute late. Some best practices. So first off, this seems obvious, but durable functions gets changed quite a bit. Minor changes, mostly performance changes and security changes. So I do recommend, and I actually recommend it with Azure Functions in general. But you know, keep using the latest version of SDK. Those code constraints, that deterministic APIs, yeah, trust me, I've seen people burn themselves and they can't figure out why things are wrong. And I'm like, how many times I got to tell you, you can't use, get date or what have you. You want to keep your inputs and outputs small as possible. If you need to pass a lot of data, put it into like a table store or a blob or what have you and have it read that instead. Azure Functions in general likes things to be small. So that's really why that comes up. Same thing, the whole entity data, and maybe part of the reason why I get burned every time I try to do that aggregator is because maybe I'm trying to put too much in it. But the big recommendation is keep that small. Stress testing. So it's real easy when you're running them, you just run one little case and everything seems to be great. What happens when that durable function is getting called a whole lot of times? So for example, we have a durable function and it only gets called once a month. But when it gets called, it gets 150,000 calls, right? So guess why I invest in stress testing? So in conclusion, we've been talking about durable functions, just a great way to add on, to have these, workflows and code, in a stateless way, right? And using the benefits that Azure Functions gives us. So with that, I'm actually out of time, but if anyone has any questions, I'll definitely be around. And then sure enough, today's mostly over, but I'm gonna hang over at the speaker corner, and I'll be hanging out there also tomorrow if you have any questions, and Friday also. So with that, thank you so much for attending. And like I said, I hope you had a great time. And there's all my contact information. Definitely feel free to reach out. And the QR code will take you to the repo, which has all the code examples and the slides. Thanks, everybody.